طيب بسم الله الرحمن الرحيم. So we're still talking about the user authentication and key distribution. So we stopped here at identity management systems. We talked about the concept of the principal, where the principal has or the user who needs to have his or her identity managed and maintained. So this user has some identity information which is managed by identity provider, right? And he also has some attributes like role, like credit card information, things like that, which are handled by the administrator or can be manipulated by the administrator, and also managed by the data consumer. So these together constitute the identity management system. And we talked about the concept of identity federation, right? Where if our identity information is maintained by certain identity provider, and we can exchange our identity information with another external system, okay? So our identity information as well as the attributes can both be either exchanged transparently or it can be mapped. Okay, so it can be mapped to another thing. So this is the identity. So this is the concept of identity federation. An example is that, like when we try to log on to any system in the university, مثلا, or even external system, and then they ask you to do sign up or just sign up automatically using your information from Google, right? So in that case, once you say sign up using Google, so once your credentials are already stored on the Google system, so your identity information will be exchanged automatically with the other system, and then you don't have to go through all the sign up steps where you have to enter manually all your information. Your identity information is automatically mapped to or automatically exchanged to our system. As part of this, you can also use your identity information inside QU, for example, to purchase some equipment from an external supplier, in which case your role inside QU as a student or a faculty member or an employee can be mapped to a user on the other system, right? So your role can be mapped. That's also another form of it maps exactly to this model, pretty much, right? Identity federation. So identity federation is in sense an extension of identity management to multiply security domains. So you have multiple security domains, and your identity can be exchanged or mapped from one domain to another. So federated identity management refers to the agreements and standards and technologies that enable the portability of identities, identity attributes, so your identity information and attributes, okay? Attributes are different. Attributes, as we said, includes the role, credit card information, things like that. And entitlements. Entitlements are privileges, okay? So based on my identity information and identity attributes, right, you have certain privileges, right? So your privileges get mapped to another privilege on the other organization. So my entitlement or my privilege as a faculty member inside QU allows me to buy, okay, equipment using, or مثلا use authenticate system, right? And have a certain quota of XYZ based on my entitlement inside QU or my privileges inside QU, right? Whereas if you have مثلا a privilege of a student, maybe your quota on authenticate can be less, something like that, right? So your entitlements, in other words, your privileges, can also be mapped and matched on the other side, okay? Another key function for federated identity management is identity mapping, اللي احنا قلنا عليه. So the federated identity management protocols map identities and attributes of the user in one domain from one domain to another. Model pretty much in a... So the way we do this is that, as we said before, this is a user who needs to get his identity or her identity managed and maintained. They have two things. They have the identity information, which is managed by the identity provider, right? And they have also some attributes and things like that, which is managed by a service provider, and also the administrator. So this graph actually, or this architecture, maps to the form of architecture like this.
So what do you mean by data consumer? So which one is data consumer?
The data consumer here is the service provider. Like, for example, the Google system itself, the generic Google system, is the identity provider, right? So Google system maintains your identity, right? Based on your identity information, you can now have a Gmail service, okay? The Gmail service manages your ID. So the Gmail server can in that case consume your identity information and give you a certain role and attributes, okay, based on your identity management inside the Gmail service. Okay? So there is identity information which is managed by the generic system, the Google system, for example, and then there is data consumer or service provider that consumes your identity information and gives you certain roles and attributes and things like that, which allows you to consume this service, a particular service like Gmail, like any other service. Okay? واضح كده؟ The administrator here can be used to manipulate the identity information or identity attributes. Okay. So for federation, there are multiple possible forms for the federation. Okay. So this is called the federation based on account linking, اللي هي ايه? Which is the example that we just talked about when we say that when we sign up on a system, we can link our account to the Google account. And by doing this, all our identity information will be exchanged between our system and the Google identity management system. So based on this linking, okay, your identity information will be exchanged with the external system. Okay? So this is the straightforward scenario. There's also another scenario, federation based on roles. Okay? So your identity information here will have some attributes like role, and based on that, when you use another external system, like in that case it's called parts supplier, okay? And our system here is like finance department at QU, for example. So your role inside QU is finance officer or a procurement officer inside QU. Okay? So based on that, there is some attributes for you, which is maintained by QU, which is now a procurement officer. Based on that, your role as a procurement officer will be mapped to another role, which is here, it's called a purchaser. So you become a purchaser on the other external system. So based on mapping the role from one thing on one system to another thing on the other system. But this mapping is automatically managed. It's not to be manipulated. Yeah. So this role is maintained through some mapping from one system to another. واضح كده؟ طيب طبعا through like the protocol of the SOAP messages, this identity federation can be chained. It can be recursive يعني. ماشي? So from one workplace system, it can be mapped to another thing and then role mapping to another external thing. Like for example, your role at QU as a faculty member, okay? QU has certain agreement with Amazon, okay? Through my role as a faculty member inside QU, I wish we could have this service. We can buy some stuff from Amazon directly, okay? By doing this, our identity can be exchanged and our role can be mapped, right? And in turn, Amazon themselves, they actually deal with multiple suppliers, right? So through that, our identity can be chained as through using the SOAP protocol, okay? Our identity can be chained to another external supplier through Amazon, right? To allow us to actually acquire the parts or the items from that suppliers, okay? So this can be done through
This system as how we access, for example, the general databases or Web of Science and so on from Qatar University?
Yes, exactly, yes, exactly. So, yeah, so through our role and identity inside QU, we have access to Web of Science, we have access to, I don't know, like SciVal, if you know SciVal, we have access to OneDrive, we have access to, I don't know, anything.
This back to the model number A, right?
Or the federation can take any of these forms or a combination of them. Actually, this one is considered a combination of these two, صح? In a chain fashion, صح? Either we do account linking. Account linking is merely to exchange your identity information, one-to-one, okay? Which is done by, for example, as we said, just by signing up on a system and linking our account to مثلا Google or to QU or whatever. So all of a sudden your identity information get exchanged to this system and your sign up is done. That's it. You don't have to really enter all your information manually. And it could be based on mapping your role or some of your attributes from the local system to the external system. Or it can be a chained combination of these. واضح كده؟
I'm having difficulty to differentiate between A and B. For example, for
لا,
A, we're copying the
صح.
we're copying
Identity
the-
information. That's it.
But again, copying identity information, even if I'm in the first system, without having permissions, I can't have access to any resource.
لا
So I
هنا.
need identity and I need a permission.
Right.
So for the next system, I need to have also
Right.
some kind of permission.
Yeah. All what this does is that it exchanges your identity information, and then here the external system can give you a role which is not based on your identity in the other system. واضح? Okay. Then here بقى the system can give you some bad default role or some different role, but here it's slightly different because you're based on your role here. Your role will be mapped to another thing. Okay? If you are a faculty member here, you will have a purchaser role here, if you're, and so on. ماشي? Or it can be a combination of both. Any other questions? واضحة كده? Okay. So, this is the summary for this chapter. In this chapter, as a summary, we discussed the concept of user authentication. And we said that user authentication is the first front line. If user authentication is compromised, then everything, all what we do has no value. Because based on this user authentication, we exchange the identity information, and based on that, we have a certain master key or a semi-permanent key. Based on this semi-permanent key, we can now, or a ticket in the case of Kerberos. Based on that, we can exchange some session key, okay? And the session key allows us to access certain service and so on, okay? Up to this point, the key thing that I want to say here, up to this point, we did not talk about any layer, okay? We did not talk about the network layers. So up to this point, if you do not have your networking layer refreshed in your mind, you are okay. From now on, it's not okay. From now on, we'll start to heavily get into the networking layers, talk about the layers one by one. And I've actually chosen this time to slightly do a different, setting where we go through the security protocols in layer by layer, because the book is not organized as such. The book is actually, it jumps between the layers.
So we're talking
Okay.
about TCP.
Yeah, TCP IP layers, yes. Starting from the network access layer, then the network layer, transport layer, okay? So now we will jump to the network access layer, okay? So we'll talk about network access layer security. واضح كده? Any question before we move on? So network access layer, network access control security. By network access layer, of course, we mean the bottom layer in the network stack, which is divided into, Network access control is divided into a
Physical.
أيوة physical and
Link layer.
data link layer.
Data link layer.
صح كده؟ network access control I will not مش زارع حاس مش هرجع I will not go back and start explaining network one. I will not do that. Okay? It's up to you to go back and refresh. This is called a network security. So network access control is composed of physical layer and data link layer. So starting from here, so we will hear the word physical a lot. Physical. So our job, our goal in this chapter basically is that we have a device or a node, physical node or a device. Okay? This device needs to have certain type of access to a network. And by network here we mean a distributed system, which is composed of some distributed nodes, servers, network devices, routers, switches, certain network with a certain topology, physical topology. Okay? Type. So to do this job, there is an entry point that this device needs to be hooked, whether physically or logically. We'll talk about that. Okay? To gain access to this distributed system, to gain certain level of access, I should say, to gain certain level of access, okay, to this distributed system. Okay? Which is physically done by two forms. Whether we have like a laptop or any device, and you have like an Ethernet cable, okay? And then you go into one of these outlets, which is connected to a switch in the back end, and then you connect it physically, okay? By doing that, we activate some security function that happens in the back end. Of course, we don't do that, but there is something that happens. Your access to the network is not granted automatically by doing this. No, there is some kind of back-end security protocol, okay, that authenticates your device. Authentication is not just done to user. Authentication is also done to the device, to the nodes, okay, and authenticates this device, okay, to the network. And this authentication entails two things. First, do you actually have any kind of access to the network? Yes or no? Okay? And this is sometimes based on whether we can authenticate your device, and the authentication can be done in multiple forms. We'll see how this is done. Okay? So you have a valid authentication. And then whether or not your device is healthy. Okay? Sometimes this health of the device is measured sometimes by whether you have like the proper patches or antivirus, things like that. Okay? If these steps are done, then we say, okay, so now you get access to the network. And the second question is, what type of access? Okay? In other words, what parts of the network, whether logical or physical, parts of the network that you have access to. واضح كده الsteps? So this is in a nutshell the goal that we want to achieve in this chapter. Okay, so here we're talking about physical devices. Okay, by logical here we mean the word logical sometimes refers to a wireless, because wireless does not have a physical port per se. It's not like we have an Ethernet port. So wireless, in many cases, we call it a logical port. And by the word port, عشان some people were confused, by the word port, we don't mean TCP port. TCP port, the TCP port or the UDP port refers to what? Refers to application. Here, no. Here we're talking about the physical port. واضح? Physical port that maps a physical address, MAC address. ماشي? So the authentication in many ways uses the MAC address of the device as an identification of that device. Similar to the user has a user ID, right? So this device has the MAC address as the identifier. Or sometimes the IP address, or sometimes both. Okay? So this is in a nutshell يعني, what we want to achieve. طيب. So network access control here talks about the umbrella of managing access to a network. Here we're talking about physical access to the network. It authenticates users logging into the network and determines what data they can have access to. And data, like, for me, it's a misleading word here because it's not actually data, it's actually parts of the network. Part of the network can be identified by physical parts, in which case what kind of switch ports you have access to, or logical, what kind of subnets. You remember the subnets? And from now on, we'll hear many networking terms. Okay? So what kind of subnets you have access to? Subnets معناها automatically, if you try to access any servers outside of these subnets, خلاص, you can't. ماشي?
Virtual LAN.
Virtual LANs, yes. Virtual LANs is also another thing. Yes. And also, as I said, also examines the health of the user's computer. The health of the user's computer. Type, the terminology which is very commonly used here is that you have the access requester, and the access requester here is the device or the node or the user sometimes that wants to have access to the network. ماشي? Also sometimes referred to as a supplicant. يبقى احنا, if we hear the word access requester or supplicant, they both refer to the same thing, whether it's the device that wants to get connected to the network, or the node, or the user, or something like that. ماشي? طيب. And there is the network access server. Network access server is the entry point, the first entry point that we get connected to, whether physically using an Ethernet port or logically using wireless. Okay, so this network access server can be a switch or access point. واضح كده? So this is also called, sometimes they call it media gateway or remote access server. Okay, and may include its own authentication services separate to the authentication server, and may authentication service from a policy server. If you see policy server here, refers to a separate system. There is the policy server. This policy server, it determines what access you should have. Okay, so this answers the first question. This answers the second question. Only the first question is whether you are authenticated and you have any kind of access to the network. If this is yes, now we go to the policy server. The policy server answers the second question. What type of access do you have? Do you have access to one physical part of the network? some logical subnet, some specific virtual LAN, something like that. So the policy server is the one that answers the second question. And to do this, we will see that the policy server in many cases is connected to back-end servers, to other back-end servers. These back-end servers maintains the topology of the network, maintains sometimes some information about your antivirus to measure or to evaluate the health of your computer and so on. We'll see how this is represented graphically. So this is the supplicant or the access requester, and the access requester connects to, first and foremost, to the entry point to this entire distributed system, and the authentication server here authenticates that supplicant, okay? We will see how this is done. This can be done in different ways. Actually, the standards in the network access control security does not dictate one form of authentication. There are multiple of them. ماشي? And then, once the user is authenticated, we connect to a policy server, which in turn checks the patch management, antivirus, things like that, anti-spyware. So it connects to some back-end servers to say, okay, so this user has a healthy computer and so on and so forth. And then it connects to the other part of the distributed system to say, okay, so based on the policy, now this device or this supplicant has access to this part of the network physically or logically or a virtual LAN or something like that. So this is the actual architecture. We didn't talk about one part, which is DHCP server. DHCP server is used to do what? To assign an IP. So that's a prerequisite step. So in order for a device to get an IP address, we have to authenticate the port that this device is using to connect to the network, right? After this, if the port is authenticated, we call it a control port, okay? We call it a control port. Once this control port is authenticated, now we call it active port. Active port, it gets assigned an IP address from DHCP. For the network access control security. So this is what we call enforcement. Enforcement is the concept of trying to restrict the access of this access requester to certain parts of the network using the policy server. So the actions that are applied to access requesters to regulate access to the enterprise network, this is what we call enforcement. ماشي كده؟ So many vendors support multiple enforcement methods simultaneously. So it can be based on spyware, antivirus, health, things like that. So they can give you certain access to, they can restrict the access for this access requester to different parts of the network. So to do this, there is a standard protocol, which is obviously is done by IEEE, which is called 802.1x. Okay, sometimes they call it extensible authentication protocol over LANs. We'll talk about this. So this protocol is authorization before a port is assigned an IP address. The port is assigned هنا. طيب, so this step is done using two protocols, which we will talk about in details in the remaining part of the chapter. We'll talk about IEEE 802.1x, which is sometimes called Extensible Authentication Protocol over LANs, okay, and the Extensible Authentication Protocol itself. So we'll talk about that. And there is the Virtual Local Area Networks, of course. This is a VLAN concept, which is we are all familiar with, which is a logical grouping of some physical ports into one logical LAN. So for example, so if you have, like here, there's a switch, and this switch has multiple, طبعا, in that case, physical ports. This is another switch here that has, again, multiple برضو physical ports, okay? And there could be like a router here. And this router is hooked to another parts of the network and so on. So each of these switches are hooked to a router port, in which case they have one LAN, one physical LAN, okay? So now, if we have a device that comes in and tries to connect to one of these physical ports. So we have to first authenticate that port. So this port is like, first it would be something like this. It's like a relay, okay? It's called a controlled port. Once it's authenticated, now it's an active port. So it becomes active. So in that case, this device gets an IP. After it gets an IP, the policy server will give it a certain level of access. This certain level of access could be for one physical LAN, okay, or a logical part of the network. Logical, by logical here we mean using by IP address or certain subnets, right? Or a virtual LAN. A virtual LAN is a logical grouping, right, between certain physical ports from different parts to form a LAN, but in that case it's called a virtual LAN. واضح كده؟ So that's what we do. After all of this, we have a DHCP, which is used to assign the IP address. So this is the layered stack of this network access layer security. So here we have the data link layer protocols. And data link layer protocols, as we all know, we have the Ethernet 802.3, okay? Or we have طبعا wireless. Ethernet here uses physical Ethernet cables, which is RJ45, and we hook it up to the wall. This is a physical port. Or wireless. Wireless does not have physical ports, but we call it a logical ports in that case. Okay? Others could be FDDI or something like this, fiber optics. Anything else. ماشي? All of these are protocols for multi-access LANs. Okay? So Ethernet 802.11, of course we have 802.11 lower Wi-Fi direct. Wi-Fi direct is not multi-access. Wi-Fi direct is point-to-point. Here also peer-to-peer, not peer-to-peer, point-to-point protocol talks about two devices connected with a point-to-point link physically. Okay? So PPP or point-to-point protocol is not multi-access. Supposedly you know that. Okay, so PPP talks about point-to-point. For point-to-point protocol, we don't need actually 802.1x calls. So that's why 802.1x is called the EAP over LAN. By LAN here we mean a multi-access networks. Okay, because point-to-point is not multi-access. So multi-access here refers to any set of devices interconnected together through some logical connection. Whether by this logical connection is like switch or Wi-Fi. Okay? Any kind of multi-access. Type. So here, so here we have the data link layer. We have the data link layer, which refers to all the physical nodes that we have in the distributed network. And then for network access control security, we have two things. We have the IEEE 802.1x, which sort of tunnels the authentication messages from above, okay, through the multi-access LANs, and we'll see how this is done, okay? And there is the extensible authentication protocol itself. the extensible authentication protocol is not actually an authentication protocol. It's actually, that's why it's called extensible. By extensible here, it means that it leverages any kind of authentication mechanism, anything, okay? And we'll talk about multiple of them. There is the TLS, which is used as part of the transport layer. We'll talk about it in the next chapter 6. There is TTLS, which is the tunnel TLS. Okay. There is the pre-shared key authentication, which is some kind of like Kerberos service, because Kerberos service uses some kind of symmetric keys for authentication. And there is IKE, which is part of IPsec. We'll talk about that in chapter 9. What I'm trying to say here is that any kind of these authentication mechanisms can be leveraged, okay, can be used by through the extensible authentication protocol. Extensible authentication protocol provides like a transport layer interface. ماشي? A transport service interface, okay, to exchange authentication messages between an authentication server and the data link layer nodes. That's it. ماشي? And we'll see the details of these messages, how they look like. As you can imagine, depending on what type of authentication service we use, the handshaking messages could be different in numbers and format, صح? صح? So that's why we need to provide a unified interface that encapsulates all these authentication messages using some unified header. It's like an interface, ماشي? And then tunnel this to the different protocols in the data link layer. Whether these protocols are multi-access protocol, in which case we have to tunnel it through a IEEE 802.1x. Or if it's PPP, then we send it directly over the PPP protocol. ماشي كده? So the messages. So first, you have the EAP header. Okay, this EAP header will have to encapsulate the incoming message. This message, if it's sent over LANs, then we have another 802.1x header, right? And then you have the actual message. And this actual message depends on the authentication server that we're using. If it's TLS, this message will have a format. If it's IKE version 2, this message will have a different format. But we don't care because we have some unified headers that allows us to exchange this message regardless of whatever authentication mechanism or authentication server we use. Okay?
In case of like PPP.
In case of PPP, this header does not exist. That's it. Okay?
And this EAP header, does it include the IP packet or IP header?
لا, we'll see the format of this header. لا, it's generic. لا, it does not. It does not. It just exchanges some sequence number of the messages and request and response and so on and so forth, but it does not have any like IP address, or it does not have any authentication information actually. Authentication information is actually is contained here. Okay, this only provides a unified interface to allow us to use any kind of authentication server in a seamless way. Okay.
Just to be sure, this is sent by the access requester.
Exactly. Yeah, but yes, architecture-wise, we'll see this is done through two steps. So there is here in this part, we'll talk about another possible messages that will be sent from the authentication server to a backend server or to the what we call the radius server. We'll see that. So the way that it's done, the authentication methods, as we said, the extensible authentication protocol provides a generic transport service. It's not on its own an authentication mechanism. خالص. It just provides a transport layer interface. That's it. Okay? For exchanging of authentication information between a client system, which is the access requester, and the authentication server in the back end. And this authentication server can use any kind of authentication mechanism. And we'll talk about most of these, by the way, in later chapters. So the basic EAP or EAP transport service is extended by using a specific authentication protocol that is installed in both EAP client and the authentication server, as we will see. And these the methods that for authentication that they are actually being used are EAP transport layer security or tunneled TLS or TTLS or the generalized pre-shared key or IKE version 2. All the details about this will be discussed in later chapters. So this answers your question back in more details. So EAP here defines this terminology, defines what we call EAP peer. The EAP peer corresponds to the access requester or the client system that tries to authenticate itself. It's the computer that is attempting to access the network. And there is the EAP authenticator, an access point or a network access server that requires the EAP authentication prior to granting access. So this EAP authenticator is the entry point of the system, okay? But remember, this authenticator does not necessarily contain the authentication protocol, which is IKE or TLS or. Okay? So this is the entry point to the network, right? But once you try to connect to this EAP authenticator, the authenticator will tell you, oh, okay, I can grant you access if you authenticate yourself first. So you need to authenticate yourself with an authentication server. Okay? So this authentication server is either TLS, IKE version 2, or something like that. Okay? طيب. Which is a server or a computer that negotiates the use of a specific EAP message. Any of these messages will be encapsulated inside EAP header. Okay? And then validates the EAP, and once this credentials back could be for a user, which is a user ID, مثلا, and as we said, we don't actually send a password. We can exchange some kind of a puzzle. Okay, so I'm giving you a puzzle which is encrypted with a key. If you know the password right, then you can know this key. Then you can decrypt the puzzle, and you can know what's inside, and so on. So that's a way to using the Kerberos. ماشي. IKE uses different method. We'll talk about it in details in chapter 9. TLS uses a different method. We'll talk about it. Okay? All of these messages that they get exchanged over EAP header, encapsulated inside the EAP header. Okay? طيب, the communication between the EAP peer and the EAP authenticator will in fact use IEEE 802.1x if it's a multi-access LAN, right? But then there is the communication that happens between the EAP authenticator and the authentication server. Okay?
This is before granting the...
Even before, yes. This is part of the authentication process itself. Okay? Typically, this authentication server is using another standard which is called radius. It's called remote authentication dial-in server. طبعا dial-in service ده very old name since we had the dial-in اللي هي through telephone وكده يعني. dial-up والحاجات دي طبعا. Some of you did not live these days أصلا. we used to actually call a phone number to connect to an internet. So this name was kind of stuck since then, and it's still called radius. Okay, so in order to see this or visualize this, so that's what we have been talking about. So this is the layered model. Okay, so the only difference here is that, so now we have the EAP peer, right, which tries to get access through the EAP authenticator. The authenticator will say, fine, I will give you access only if you validate yourself, okay, through a authentication server. Okay? Then, by doing this, the peer, the EAP peer, will send some messages using EAP protocol, which is tunneled or encapsulates 802.1x or PPP. 1x في حالة الايه multi access LANs and PPP في حالة point to point LANs or point to point nodes. Okay, so this will go through the authentication server and then will be tunneled through the radius protocol to the authentication server in the back end, whether this is بقى IKE or TLS or whatever. Okay, of course, this can in fact be integrated inside the authenticator device, physically. Okay, but in terms of layered architecture, it could be separate. Okay, the EAP messages we call it pass-through messages. So pass-through messages meaning that the EAP messages, which encapsulates the authentication messages, they go through the authenticator, but the authenticator doesn't do anything with them. Just relays them to the authentication server. So the EAP messages for the EAP authenticator, they call it a pass-through messages. Similar to the fact that the router receives some kind of messages that has TCP header. Does the router actually process the TCP header? No, the router processes the IP and then it re-encapsulates the message again and then it sends it. صح كده? So that's the same concept. So the EAP authenticator, it doesn't do anything other than decapsulates. This is EAP header. Okay, I encapsulate through radius and I send it to the authentication server. But I don't actually do any processing to it. Okay, so in fact, the authentication process will be done through interaction between the EAP peer and the authentication server, right? I will exchange messages with a format and number, okay, which is based on the authentication method that I'm using, whether it's TLS, IKE version 2, pre-shared key, whatever. So the number and the format of these messages are not known to us. It depends on what kind of authentication method that we use. Okay? So the message format طبعا message format here refers to the header of the EAP message. So the header of the EAP message contains the type of the EAP message. So these are codes which can be one in the case of I want to request something. So request معناها I'm sending a request to the server and the server is sending me some reply. So this is the request response. And then at the end, the server will say success or failure. Success meaning that this control port is now authenticated, or this control port is now not authenticated, which means it's open and I cannot send anything on it. And it happens, I'm not sure if it happens to some of you, but sometimes we hook up an Ethernet to the port and then we open and then nothing works. Okay? This is not because of the fact that the network is not working. It's because of the fact that based on the MAC address, based on the software on your device, this device cannot have any kind of access to the network in any way. So the physical authentication has failed. ماشي? So in addition to the code, you have identifier. Why? The identifier is used to correlate the request with the response. Okay, so this, because sometimes there is some multiple requests that happen from multiple physical nodes. Okay?
Because we need to identify the requester. Because there
Right,
is many
right. So in other words, these messages are sent asynchronously. So it can be sent from multiple nodes, right? And then we need to identify which response belong to which request. And there is, of course, the length, because again, we don't know the content of the data itself, because the content of the data itself depends on the authentication method نفسها, صح? And we don't have the details of this, or EAP does not have the details of this. Okay, so it just reports the length of the message and the data which contains the actual authentication method. واضح كده؟ So the way that this works is that, okay, so the authenticator, based on the fact that we hook up the port to the wall, right? So the authenticator, whether this authenticator is the access point or the switch, okay, it triggers an EAP request. It tells the device, okay, I can give you access only if you authenticate yourself. So there is a request that goes to the EAP peer, which is the client system, to initiate the authentication method. And then starting from here, we send response messages, and we send request, response. The number and the format of these messages, as we said, for us is details. We don't know the format of these. We don't know the number of these, because it depends highly on the authentication method. At the end, what we care about, whether we have success or failure. If it's success, this means that the control port is now authenticated. If it's failure, means that this control port is not authenticated. واضح كده؟ Okay. So that's how it looks like. So this is the supplicant or the client. Well, it keeps using different terms. معلش, don't be confused. So the supplicant is the client system, is the access requester. We keep hearing different names, but they refer to the same thing. So this access requester or the supplicant tries to connect to the. طبعا there are some hidden steps here which we did not talk about, because here we have access points, and for access points, before the EAP request, before the EAP authenticator sends the request, there are two steps that happen which we did not talk about here in the case of wireless in particular, because for wireless you don't actually hook a physical port to the wall, right? No. What does happen before we do that?
need to provide the key, right?
لا مفيش كي لا مفيش كي
Wireless key?
لا مفيش وايرلس كي. وايرلس كي الكلام ده وايرلس كي والكلام ده لا حاجه ثانيه. Wireless key is used to facilitate this authentication, but this is another thing. There are two steps that happen. First, there is the wireless discovery. So your client system discovers all the possible access points that exist in the surroundings, right? Leia, when you click on the lower Wi-Fi بتاع Windows, you see list of available networks, right? So this is called access point discovery. And then you need to associate yourself to one of them. Okay? By associating yourself to one of them, this is equivalent to the fact that you have an Ethernet port and you hook it to the wall. By doing this association, then you trigger the EAP authenticator to send a request to authenticate yourself using passphrase. Passphrase is like some kind of WEP or WPA. We'll talk about this in the next chapter. Okay, so this is some kind of authentication that happens between the access point and the EAP requester or the supplicant. طيب, so this is the control port that we are trying to activate through the authentication. So if we authenticate ourselves to the authentication server, and the answer is success, we can now have access, then it's like this port is closed, and now we have an authenticated port, so we can have access to the network. I should also highlight here, this is uncontrolled. Why uncontrolled? Because this port is not to be activated through authentication, because this is used for authentication, صح? So this port is not controlled because it's actually the connection between the access point and the authentication server. ماشي؟ So the EPOL, which is by the IEEE 802.1x, okay, this refers to the same thing, okay. It contains some برضو messages as part of the standards, which is called EPOL, okay. So this contains an encapsulated EAP packet, which is a over LAN. OL here stands for a over LAN, over multi-access LAN. And again, it has like the start, and it has log off, which happens at the very end. Once you finish all the communication, خلاص, then you end the communication. And there is the EPOL key. The EPOL key, this is the key that gets exchanged once your authentication is done. مش احنا قلنا ان authentication, the outcome of the authentication is that you have a semi-permanent key, which you can then use for to establish some communication. So what happens is that first you start by starting here, you initiate the authentication through the EAP, and then you exchange the messages. خلاص, authentication is done and it's success. Then you get a key. Okay, so you get a key and the key here is calculated on both sides. ماشي, which is a semi-permanent key, which we can use to exchange or to encrypt a message that contains some session keys. Okay, and then we use that key for communication, for secure communication between the physical device and the network. So all your communication between the physical device and the network will be secured in that case. Okay, after you finish all the communication, we say you activate a message which is called log off. Log off, خلاص معناها خلاص, you don't need to access. It's equivalent to the fact that you say I want to disconnect from this wireless LAN, which means خلاص I don't want to connect to this wireless LAN. So all the keys, everything, what we call the security context, gets dismantled. خلاص, it vanishes. So this is the EPOL start, which goes from the EAP peer and the authenticator, and then we exchange the EPOL. طبعا EPOL, and then EAP. So which means that you have the EAP header, which encapsulate inside it EPOL header, صح؟ مش احنا حطينا كده الفريم في الأول. And then the message itself, which is the message that contains all the authentication information. Okay? So you have a complete protocol data unit. It contains the extensible authentication protocol header, and then the EPOL, which is the IEEE 802.1x header, and then the message that contains all the authentication information. And this authentication information is sent with a number and format which we don't know, okay, so far. And then once we have success, this means that now we have a key. Success معناها now we have exchanged a semi-permanent key. So at this point, this EAP peer should have a semi-permanent key, which can be used for communication. عشان كده في هنا نقط بقى. You can use it for communication back and forth. Once you are done, then you say log off. Log off معناها خلاص, I don't want to communicate anymore. ماشي? So we'll talk about the case of wireless, and we'll see how this authentication is done in the case of wireless. اللي هم the details about these messages. Okay? In wireless in particular. Wireless itself has some particular features which makes it really challenging and complicated. So we'll talk about that in the next step. But طبعا we'll have some break before people will break. So in this chapter, it's a small chapter. But then when we talk about the wireless access protocol, we're still in the network access control layer, okay? But instead of talking about the physical ports, now we'll talk about wireless. So why actually wireless is really challenging? So we'll talk about this in the next chapter. So the next chapter, which is chapter 7, but not 6. So we'll jump to chapter 7, is divided into actually 2 parts. The first part is actually some review about wireless, why wireless is challenging from a security perspective, what are the characteristics of wireless that makes it challenging, what are the attack services that exist, and so on. And then we'll talk about the actual security protocols in wireless, which is WEP, WPA, WPA2, and the differences between them. Okay, so the network control, network access control security. Now we go to the same layer, but now we'll talk wireless back. So wireless network security. So there are some of the key factors that contributes to the fact that for wireless we have to think differently. يعني fundamentally different. أول حاجة the nature of the wireless channel. The nature of the wireless channel is that it's broadcast in nature. Okay? يعني all wireless communication is through one hub broadcast. صح? It's not guided. Okay? So wireless signal travels in space, which means that eavesdropping is granted. Okay? So any eavesdropper, no matter what you do, will in fact read the signal. Okay? And not only that, it facilitates also some vulnerabilities which we haven't thought about before, which is jamming. For guided communication, we don't have to worry about that. It's not broadcast in nature, صح? And it's not to be jammed. Then it has to be physically كده take the port out in order to disconnect. But for wireless, just by knowing the frequency of the wireless signal, you can just send a high power signal in the same frequency to cause some interference. Okay? If you increase the power of that signal, then you can jam any wireless signal in that frequency range. صح كده? So that did not exist before. Also, mobility. Wireless was done to facilitate mobility. Mobility gives us really great flexibility, so we can move from one place to another. But طبعا this makes the devices portable. Okay, so we have portable devices that allows us to have mobility. But this initiates some challenges which did not exist before. Okay, on one hand, these mobile devices, they don't have unlimited power since they are not wired, right? Because they are portable, so they have to have battery. Battery معناها limited power capacity. معناها there are some limitations on the computational capabilities of this wireless device or this portable device. Okay? So this also mobility results in a number of risks, because I can move my laptop from one place to another, and sometimes I don't have control, okay, on the network that this device connects to. It can connect accidentally to a network even without me knowing that. Some open wireless network which is available and I don't know about it, and all of a sudden I'm moving and I have مثلا my cell phone, and all of a sudden my cell phone finds an open network, so it might actually connect to it, okay, accidentally, okay. So this actually might initiate some problems, because I don't trust this network and I do not guarantee the security mechanisms and the security policies implemented on this network. Okay? Resources, we talked about it. So some wireless devices such as smartphones and tablets have sophisticated operating systems but limited memory because of this portability issue. Accessibility برضو, some wireless devices such as sensors and robots may be left unattended. بمعنى ان some wireless برضو allows us to deploy plenty of these wireless devices very easily, صح? In the environment. Okay? But doing that opens the door for anyone to go and physically hijack these unattended devices. Okay? Because we left them unattended, open, and same thing might happen. You move with your wireless device and you leave it somewhere, somebody might hijack this device, and this is called by physical attack. Okay? So this greatly increases the vulnerability through physical attacks. Okay? All of these are very distinct factors for wireless that in fact initiated some attack surfaces which we did not have before. Okay? Therefore, we have to think about wireless differently. So when we talk about the wireless access architecture, we see that there is great versatility and diversity to the different parts of this architecture. Starting from the endpoint. This endpoint can vary from literally a nanorobot, right, which has a microscopic form factor, okay, all the way to a gaming laptop. صح? This diversity initiates also some challenges from security perspective, because the security protocols that work on nano robot or nano device should not be the same like security protocols that work on humongous gaming laptop with GPU. صح? Wireless itself, wireless medium itself, has lots of impairments. The wireless signal itself has lots of impairments. Actually, this is, يعني if you you know the details about this in the wireless communication course, يعني there are enormous amount of impairments in the wireless signal that really you need to understand really well. So fading, multi-fading that happens through the walls, the frequency characteristics, the interference between the signals, because they coexist in space, right? So the interference between these wireless signals initiates some kind of impairments to the wireless medium, which we did not have to talk about in the guided communication. For guided communication, you have a wire, صح? And communication through a guided, whether it's a wire or fiber optics or something like this, all these issues do not exist. But here, I can also initiate some kind of jamming by sending a wireless signal with very high interference. High interference معناها very high power on the same frequency range, which allows this access point or the endpoint to not have communication at all. Okay? So how are you going to mitigate jamming? Jamming is some kind of denial of service attack, but from the physical layer. Okay? Denial of service attack, but from the physical layer. ماشي? So I'm sending very high power wireless signal. Also, diversity for the other side, because this also can range from like a Bluetooth kind of device, which this device can act as an access point using Bluetooth or Wi-Fi Direct or something like that. صح? And it can be like a base station tower, which might span like a big geographical area with power generators. صح? So there is diversity here, and there is lots of impairment in the middle. So that's what this wireless communication entails. And of course, because of these characteristics, it kind of enforces lots and lots of challenges when it comes to security. واضح؟ طيب. So these are some of the يعني threats or some types of scenarios that really cause some attacks to happen. And most of them, they are facilitated because of the characteristics of wireless. So, for example, accidental association. Accidental association here talks about the fact that you are carrying your laptop, you are getting into the boundaries of some perimeter of a network. ماشي? Like you are driving your car with your cell phone, and all of a sudden you have access to another wireless network, and accidentally you can get connected to it very easily. This network is kind of open. It does not have any passphrase. It does not have any security mechanisms implemented. And all of a sudden you are connected to an untrusted network, to an open network that might impose some threats and some attacks, not only to your device, but it can use your device to attack even the QU network. Okay. Malicious association here. In a wireless device is configured to appear to be a legitimate access point. So you are trying to authenticate yourself to an access point, and I come in the middle and I say, oh, okay, I'm the access point. Connect to me. And then it's like man-in-the-middle attack. Man-in-the-middle attack. So it performs man-in-the-middle attack between the wireless node and the access point. Okay. Ad hoc networks is even more challenging because we're talking about wireless. Wireless is divided into two things: infrastructure wireless, which you have a wireless node that connects to an infrastructure. This infrastructure has like an access point or a base station tower that provides wireless access to a network. صح? A network infrastructure. So starting from the base station or the access point, the remaining part of the network could be wired. صح?
Yes.
صح? Could be wired, right? In ad hoc networks, we do not have any infrastructure. We have wireless nodes that communicate to each other in peer-to-peer fashion. This is much more challenging. Why? Because any node in the ad hoc network may in fact perform the functionality of the access point or the wireless router or. Okay? So we are all peers communicating to each other. Why do I have to trust you? صح? Why do I have to trust you? At least if I'm connecting to a QU network infrastructure, I trust the QU infrastructure. But if I'm communicating to you directly without the engagement of the infrastructure, what actually, why do I have to trust you? There's no guarantee that these nodes can trust each other. This is quite a challenge. ماشي? Non-traditional networks here talk about personal network Bluetooth devices, barcode readers, or handheld PDAs. For these types of devices, you can have access to content very rapidly. Just we go around now and we can use our cell phones to read barcodes, to read QR codes, to read, and these content might have like a huge amount, and they might be actually malicious. They might infect our devices. I can read hundreds of lines of data using QR codes, right? And I don't know what's inside. Before I actually read the QR code, I don't know what's inside. I can actually read some data that can harm my device. So these types of non-traditional types of wireless access to content might impose some threats. Identity theft, which what we call MAC spoofing. In Network 1, we have studied the concept of spoofing through any kind of broadcast protocol. Broadcast protocol like فاكرين ARP. فاكرين ARP protocol, which is used to map IP address to physical address, right? These types of protocols, they use broadcast to send a request to everyone. Like I'm trying to search for the device with a specific IP, okay? And this device should give me the MAC address so that I can use MAC address for data link layer communication, صح? So ARP in network 1, we did not have any security background. So we kept telling you, so there is ARP request and ARP reply. ARP request is in a form of a one hop broadcast. I'm asking anyone in the class. Anyone in the class has this IP, please respond to me with the MAC address, صح? So any of these protocols, okay, send a broadcast message, and this is inherently exist in wireless, of course, because wireless is based on broadcast, right? So I'm asking everyone, give me your MAC address. Anyone can respond to me and say, oh, here is my MAC address, and I'm the one, and A communicate with me. So now we have to think security back, okay? So this is a MAC spoofing. I can tell, oh, okay, here is my MAC address, and I'm the guy. I'm not the guy. I'm pretending that I have this MAC address, and I'm doing some MAC address spoofing. So any kind of broadcast protocol has this type of threat. And ARP is just one example. Man-in-the-middle attacks, we talked about them. Any kind of man-in-the-middle attack, and this inherently exists in wireless, and particularly in ad hoc networks, because any node in the ad hoc network is man in the middle. So we don't have any infrastructure to trust. So if you try to communicate to anyone peer-to-peer, anyone can get in the middle and perform some kind of attack. Okay. Denial of service. Denial of service is an attack that exists in all systems, except that in wireless, what's different? We can do attacks in the physical layer. We can do denial of service attack in the physical layer using jamming. بالظبط كده. So we can do jamming as a form of denial of service attack from the physical layer. That did not exist in other types of networks. Network injection. Network injection here is an interesting concept. So we have a node. We said that a node, مثلا any type of node, can get access through a switch or اللي هو سميناه authentication server or network access server. Through this, I can get, this is logical or physical, doesn't matter. I get access to a network, right? So once we connect and authenticate this port becomes authenticated port, and I'm now ready to communicate. So assuming that the port is authenticated and life is good and everything. So I can send messages to the network, right? But I can also send some routing messages. Okay?
That I'm the router.
Eh?
I am the router.
Yeah, it's like,
So router.
yeah, I'm sending some routing information, like what? Routing information, route updates. If you have studied dynamic routing protocols, there are route updates, okay, that gets exchanged between the routers, right? So what if a node sends some kind of routing messages through the network? What is the implication of this? It can, in fact, affect the routing decisions, which stops or reduces the efficiency of the routing inside this network. Because I'm telling مثلا rep ولا OSPF ولا كده route through this node instead of routing through this node مثلا. I'm sending some messages that affects the routing decisions fundamentally, which will affect the functionality of the network. So these types of routing messages, okay, should not be sent from a node. It should be sent from trusted routing nodes or routers. صح? So this type of messages coming from a node, we call it a network injection. So we inject some network layer messages, whether it's routing, it's ICMP messages for ping, whatever. Okay, we are sending routing level messages inside the network to kind of cripple the network functionality from the routing layer perspective. Okay, so this is called a network injection. مفهوم ولا مش مفهوم؟ مفهوم يعني؟ Dynamic routing protocols define what we call route updates. Okay? These route updates, like for example, routing information protocols called REP or OSPF, EIGRP, all these are dynamic routing protocols. Inside this network, there are certain routers, okay, that exchange these routing updates between them. Through these routing updates, each router will decide, okay, so if I get a packet with this particular IP address, I will in fact send it this way, not this way. Okay? So this is the basic routing functionality. In order for the router to do that, okay, the router needs to exchange these messages between all the routers. Okay? So what I'm saying now is that this node can perform what we call network injection attack. It can send some of these fake messages, okay, through the network. So it goes to the routers and it kind of deforms or corrupts the routing table with some fake messages. So the router will receive this kind of fake route updates and will say, oh, okay, so I need to put in the routing table some entries based on this route updates, okay? So, and by doing this, the routing table becomes corrupted. So each of these routers will have routing table, which now will be corrupted with some of these network injection messages that comes from a malicious node.
How will the router accept them?
أيوة ما احنا بنقول بقى, in order for the router to accept these, it has to come from a trusted source. So we have to do a message authentication, we have to do all kind of security implications عشان نتأكد.
Just the routing protocol to improve the security of the routing protocol.
Right, so يعني what I'm trying to say is that this routing protocol needs to be برضو secure. ماشي؟
But Doctor, I don't understand if this is specific to wireless network.
Yeah, here we're just talking about the fact that if this is a wireless, if this is a wireless port, which means logical port, now in QU مثلا or in any network, you have millions of devices that can come and go at any point of time. It's very easy, fam. Wireless gives you some portability, so you can have millions of these devices. يعني مثلا, for example, you have some visitors coming. Each of these visitors, they have 3-4 wireless devices.
Okay,
will you allow them? Will you allow them to connect to your network? You cannot. Sometimes you cannot say no.
In this situation, then we are talking about how the routers are communicating.
أيوة, ما هو الفكرة بقى إن أنت these nodes which you allow them from a network access control perspective, you allowed these visitor nodes to come to your network, right? So implicitly you have some level of trust. So what will prevent these nodes from injecting some routing messages to your network? خد بالك الrouting messages, some of these routing messages, by the way, they use TCP, they use UDP. So any of these nodes can send some routing messages to your network and you don't know. How wireless increased the scale of what the possibility of this to happen.
So it's possible.
Okay, yeah, it's more possible with wireless because of the fact that in many cases you have visitor nodes that come to your network, leaving your network at any point of time. Okay. طيب. So the concept of accidental association ده بقى الفكرة when you connect to the accidentally or sometimes on purpose. يعني مثلا you're taking your device and you are مثلا traveling, okay? You are staying in a hotel you have access through the wireless network to the network of the hotel, right? And all of a sudden you are actually checking your email inside QU from this network. Okay. So now there's يعني big implication now, because you don't trust the network, and QU cannot trust you, even though you are a legitimate user inside QU, but you are accessing QU's network from another external network which is not trusted. Okay? And all of this is facilitated through wireless because of this portability issue. ماشي? So securing wireless transmissions, for wireless, as we said, we have two steps which we did not talk about in the normal wired network access, which is a discovery and association, right? So how do we secure these two steps? Sometimes the networks or the wireless LANs, they announce about themselves, right? So by announcing about themselves, this increases the possibility of many users coming and connecting to these networks. Okay? So after connecting to this network, they can associate themselves and they can perform some attacks, whether by network injection or something like that. So to deal with eavesdropping in wireless, there are two types of countermeasures that are appropriate in that case. One is signal hiding techniques, because wireless signal is broadcast in nature, and we said broadcast in nature معناه ان احنا we facilitate eavesdropping no matter what we do. So one way of doing that is to say no, I'm not going to announce about myself. I will turn off SSID. You know SSID اللي هو wireless network identification. Okay, so when if you open your wireless settings, you see مثلا QU user, QU secure, and so on and so forth. You see all the available wireless LANs that exist in any location, right? So one way is to say, okay, so I'm not going to broadcast my SSID. What is the other alternative? If you want to if you want to connect to the network, you need to know the SSID manually, and you need to enter it. And there is a way to do that. In the settings, you say, I want to connect manually and give it the SSID. So by doing this, you kind of reduce the possibility of devices connecting to your network. Assign cryptic names to the SSID. That's another thing. Reduce signal strength. This is an interesting one. To lowest level that still provides requisite coverage. What does that mean? This means that the announcement will not be sent with enough power to broadcast in a very large domain. So you try to limit the domain of how you want your wireless access to be. So it should be in a small jog. And how can we control the range of the wireless signal? By controlling the power. We control the power of the wireless signal. We allow the wireless signal to travel far or close, right? So we can reduce that through the power. And by doing this, we kind of limit the perimeter of the wireless access. Locate wireless access points in interior of the buildings. So again, to prevent this accidental association to happen, okay, don't get the access points very close to مثلا the window or the boundary of the organization. Okay, خليها in the middle, so that you don't have any accidental association from any device that tries to move just outside the perimeter of your network. So try to make it in the interior, inside, and to be more secure. Yeah. So this is to use like some special information to secure the network. Encryption and authentication are effective طبعا against طبعا this is the other thing, and for that we will study all the protocols, the WEP, WPA, WPA2, which we will study as part of this chapter, but possibly next lecture. Denial of service can also be countered through site surveys, and by here we mean site surveys معناها Site surveys معناها إن إحنا we do some frequency measurement, okay, in a specific area to know which frequency ranges are busy, which frequency ranges are not busy. And here we try to avoid the accidental jamming, or in other words, the interference. Here we're not trying to mitigate jamming attacks, because jamming attacks are on purpose. Someone is trying to actually see what frequency range you are using and jamming on this frequency range. No, here what we're trying to do is try to mitigate the accidental jamming اللي هو الانترفيرنس يعني. So you have some other مثلا access points, base stations around you, okay, that work on the same frequency range. So in a way they are performing implicit jamming or interference on your wireless network. So by doing certain measurements, or what we call here site surveying, so you know that this frequency range is مثلا the range of the Ooredoo tower. This frequency range is the range of Vodafone tower. Okay, so I need to avoid these frequency ranges and use frequency ranges which are different so that I can avoid any kind of interference coming from these types of base stations, or also impose some interference on them. Okay. طبعا Wi-Fi itself has implicit interference avoidance through the concept of auto channels. So Wi-Fi actually, once you start any wireless device, it kind of probes all the frequency ranges and then it decides on what channel to use. Okay? So that's some of the mitigation or countermeasures that we can use to secure wireless access. So the main threat involving wireless access points is unauthorized access to the network. This is what we want to avoid. ماشي? So we talked about the protocol that is used to provide the security for any kind of multi-access LANs, which is a 2.1x. So we talked about it in the previous chapter. So that one is used for any kind of multi-access LANs, whether it's wired or wireless. So wireless is no different. So we will use that in this chapter as well. The standard بقى for wireless provides an authentication mechanism, specific بقى authentication mechanism, for devices wishing to attach to the LAN, and the use of 802.1x can prevent the access point and other unauthorized devices, and we'll see how this is done. So of course, like any other system for wireless, we can try to avoid the attacks as much as possible. And these are countermeasures that are actually mentioned in one of the standard documents. So we can use encryption, and in fact, of course, eventually we have to use encryption, but before encryption, we have to do authentication. So we have to authenticate the device or the user who is trying to access the wireless network first, before we do the encryption. Similar to what we talked about, also we can use antivirus, anti-spyware, and things like that to again allow the access to happen or not. Turn off the identifier broadcasting, as we said, turn off the SSID or something like this. Change the identifier on your router from the default. Sometimes you have a wireless device that comes with a predefined default identifier, SSID. Okay? So the SSID, the default SSID, if you try to just turn on the wireless router at home without changing anything, chances are everybody will know your SSID because it's the default. So they can perform any kind of automatic attack using this default SSID. But the first thing you should do is to go through the wireless router configuration and change the SSID. But that's not enough, of course. You have to change the SSID, and then you have to also set some security protocols, which we will talk about. Also, some of these routers, they come with default admin. So, the wireless router comes in many ways preset with some passwords, user ID admin, password admin. So, if you leave it without any changes, so chances are anyone can get to your wireless router easily and can change the configuration, because again, it's wireless router, so you can connect from it. So my neighbor my neighbor in the next home can actually connect to my wireless router configuration and say admin and get inside and change everything, and all of a sudden I don't have any communication. And so the first thing you should do is to configure the wireless router and change all the defaults to some specific values. SSID, change the preset user ID and password, and so on. Okay? Another thing is to allow specific computers. Based on what? Based on MAC address, based on IP address, based on both, combination of both, something like that. Which, يعني, in a way, you are doing some kind of firewall rules. We'll talk about firewall in a later stage. The mobile device has become an essential element for organizations as part of the overall network infrastructure. Prior to widespread use of smartphones, network security was based upon clearly defined perimeters that separated trusted internal networks. So for wired networks, before the widespread of the wireless, the network perimeters, by perimeters there I mean the boundaries of the network, was quite fixed. صح? Because you have wired devices that hooked up to each other through routers, through switches, through something. So the network perimeter itself is kind of well defined and fixed, and it does not change. المشكلة بقى with wireless, the network perimeter itself becomes like fuzzy, صح? Because it depends on the range of the wireless signal. You can have accidental association from other nodes coming to the net. So the perimeter itself of the network becomes really fuzzy. It's not well defined, and it's not fixed. It's dynamic. It's quite dynamic. Okay? So this is, of course, due to massive changes, and organizational networks must now accommodate growing use of new devices, cloud-based applications. All of this has led to the fact that you need to provide some mobile services, which enforces some challenges related to this dynamic perimeter. ماشي؟ طيب. ماشي. خلينا نستوب هنا. خلينا نستوب هنا ماشي.